Now it gets more complicated because it's not always plain old x and y. So we're going to do our combination method just to get some practice on this. 4, 0, 4, 1, 4, 2, 4, 3, 4, 4. And let's go ahead and fill in those coefficients before I do signs. We know 4, 0 is 1, 4, 1 is 4. We just did this a second ago. We know this is 6. 4, 3 is 4. 4, 4 is 1. Everything's positive. I'm filling in positive signs. And this is where you need to be careful, and I want you to use parentheses. X to the fourth. Now, I realize it's plain old x. I really don't need those parentheses, but I want you in the habit of doing those. This is x to the third, x to the second, x to the first. And I know I didn't need those parentheses at all, but here are parentheses I do need. This is the entire 3y raised to the first power, 3y raised to the second power, 3y, the quantity raised to the third power, and 3y, the quantity raised to the fourth power. And that's why I wanted you to put the parentheses around the x's, not that I needed them, just so that you're in the habit when you see coefficients, you've got to have those parentheses. So if you didn't put parentheses around the x's, that's no big deal. Now, this is going to change some arithmetic. From here on, it's just arithmetic. 1 times x to the fourth is x to the fourth, plus. Now, 3 to the first is 3, times that 4 is 12, but it's x cubed, y to the first, I'm not writing the 1. This is 6 times 3 squared is 9, so that is 54, x squared, y squared, plus 3 cubed is 27, times 4 is 108, x, y cubed, and the last is 3 to the fourth is 81, y to the fourth. Now, when you have an expansion like this where you had coefficients, that's going to change the coefficients in your answer. It's not going to be the same 1, 4, 6, 4, 1 coefficients. But what does stay standard is your powers. 4, 3 plus 1 is 4, 2 plus 2 is 4, 1 plus 3 is 4, and that's 4. Also, the x powers down from 4 to 3 to 2 to 1 to gone, etc. All right, let's do 3v minus 2p to the sixth. So as far as my combinations, it's 6, 0, 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6. And if you just don't want to do the combination method for this, then you go back to the Pascal's triangle where we stopped at 5 and you write out the coefficients here. 1, 6, 15, 20, 15, 6, 1. And those are the coefficients you would use, but I'm sticking with this right now. So 6, 0 is 1, so is this. 6, 1 is 6, so is this. 6, 2 on your calculator, or using your triangle back here. 6, 2 is 15. So this is 15, this is 15, and this is 20. The next thing I need to deal with are the signs. And just remember that the signs on these are going to alternate from positive to negative, positive to negative. So that's a positive, that'll be negative. That's a positive, that'll be negative. That's a positive, that'll be negative, and that's a positive. And I'll tell you why in a second. Just go with it right now. It alternates positive, negative, positive, negative. So my first will be 3v in parentheses to the sixth. And keep writing this out. 3v in parentheses to the fifth, 3v in parentheses to the fourth, 3v in parentheses cubed, 3v in parentheses squared, 3v in parentheses, and no 3v at all. And then get our powers with the y's. This will be 2p to the first. And you're saying, wait a minute, it's not 2p, it's negative 2p. Yeah, you're right, it is negative 2p, but I have already accounted for the fact that it's negative. Now, pretend for a second that I really did put the negative right here. A negative 2 to the first power is why this sign ends up negative. So what I say is just alternate your signs, and you don't have to worry about putting a negative in parentheses there. So this will be 2p squared. And see, in reality, it is a negative 2p, but a negative raised to the power of 2 would come out positive. So then this is 2p cubed. I did leave myself enough room. 2p to the 4th, 2p to the 5th, and then this is 2p to the 6th. All right, 3 to the 6th on your calculator is 729, b to the 6th. Now, your choice for what you do here, you can write out these steps. You can write 6 times, use your calculator. 3 to the 5th is 243. 2 to the 1st is 2. And then multiply those up, which is 2916. B to the 5th, P to the 1st. Or you can use your calculator and type in 6 times 3 to the 5th times 2, or 2 to the 1st, or whatever the power happens to be, and that's how you get to 2916. So that's a little bit faster. So for this one, I will type in 15 times 3 to the 4th times 2 squared. So that gives me 4860 b to the 4th p squared. I had to write real tiny. That is a little p right there. Minus this one, I'll do 20 times 3 cubed times 2 cubed, and that gives me 4320 b cubed p cubed plus 15 times 3 squared times 2 to the 4th, which is 2160 b squared p to the 4th minus 6 times 3 times 2 to the 5th, which is 576 v p to the 5th, and the last is just 2 to the 6th, which is 64 p to the 6th. So you've lost your symmetry as far as your coefficients. The front and back are no longer the same. But the exponents should work the same way. V to the 6th down to v to the 5th, v to the 4th, b cubed, v squared down to v, no v at all, no p at all, p to the 1st, p squared, p cubed, p to the 4th, p to the 5th, p to the 6th. So that is a long expansion with coefficients with your variables, and you also had to deal with the minus right there. Now, this one asks me to find a particular term. When you're asked to find a particular term, you don't want to have to write out the whole expansion. There will be a nice little way to do this, but to develop that, I want to look at my fourth term. All right, the fourth term, the coefficient is 6,3. Before we go any further with that, we've got to understand why this is 6,3. It asks for the fourth term, which might make you think this should be 6,4. But remember, with our combinations, we started with 0. So for the fourth term, our combination here is 6,3. This number right here is 1 less than the term you're asked for. Then what else do I have? I have up there a 3v cubed. I also have a 2p cubed. Now, in reality, that's not really a 2p. It is a negative 2p. Now, when I did this expansion, I ignored the negative. Here, I'm showing you that you can keep the negative and then let the power take care of it. A negative raised to an odd power will give me a negative. The other way to go is to ignore the negative and think about what position you're in. The first term is positive. The second term is negative. The third term is positive. The fourth term, which is what I want, is negative. So that's the way I do it. I think about what position I'm in, and I slap a negative on if it's in a negative position. I don't deal with putting the negative there, but that is something you could do. You could put the negative raised to an odd power, gives you a negative. Now, the next thing you want to figure out is why are these powers both 3? Now, I know 3 plus 3 gives me 6, but that doesn't help me for the individual powers. And the way I do this is I say the bottom number here goes to the back parenthesis, because your bottom is attached to your back. The bottom goes to the back. Where did this 3 come from? Well, we know these two have to add up to 6. So let's take a look at a new example without the whole thing written in front of us. We want the 6th term. So take away 1, which gives me 5. That means my combination will be 7, 5. Then I write 4x. Then I write 2z. And I look at the fact that this is a 5. The bottom power goes to the back. So this is a 5. This is a 2. Now remember, I deal with a negative sign by position. The 6th term, positive, negative, positive, negative, positive, negative. That's my sixth term is negative. Or you could stick a negative right here and let the power take care of it. So for this arithmetic, 7, 5 on your calculator is 21. Then you could type in times 4 squared times 2 to the 5th, and that works out to be 10,752. Go back and get your powers, x squared z to the 5th. And that is your sixth term. So we just built that piece by piece. We got our coefficient, then we filled in our powers using that number down there to help us. We decided it was negative, then we let the calculator do the arithmetic. This next one says find the middle term of this. Well, I can't do middle minus 1. I need to know exactly where the middle term is. Remembering that if this is 2x plus y, 5y to the 8th, there are 1, 2, 3, 4, 5, 6, 7, 8, 9 terms. The middle will be right here. And what position is that? That's the 1, 2, 3, 4, 5th position. So this is the same as I'm saying, find the 5th term. So we had to do some finagling here to come up with the fact that they want me to find the 5th term. Subtract 1 from that tells me that this combination will be 8, 4. There's my 2x. There's my 5y. The bottom power goes to the back. And in this case, it's also 4 because 4 plus 4 gives me 8. And then it's just arithmetic. 8c4 on your calculator is 70. And then times 2 to the 4th. And then times 5 to the 4th comes out to be 700,000 x to the 4th, y to the 4th. That looks like a 6. That's a 4.